Hello everybody. Today I'm going to explain and demonstrate what is sound intensity. Sound intensity is the rate of flow of acoustical energy per unit area. So sound intensity is nothing but the flow of sound energy per unit area. So the rate of flow of sound energy, which is nothing but sound energy over time, is nothing but sound power. So sound intensity is also sound power over unit area. So it is a measure of the power carried by the sound over the area and propagating in a direction perpendicular to that area. Alternatively, sound intensity can also be defined as the product of pressure and particle velocity. This is a very important relation and it is used to experimentally determine the sound intensity. Now if you note here, pressure is a scalar quantity and particle velocity is a vector quantity. And the multiplication of scalar and vector gives a vector quantity, which means sound intensity is a vector and it describes the level and the direction of flow of acoustical energy. Now, what is sound intensity level? Well, when you say something like level, it is nothing but it is the measure of the quantity relative to some reference value. So here, sound intensity level is the measure of the instantaneous intensity with respect to a reference intensity. And what is this reference intensity? Reference intensity is the intensity of the faintest possible sound that a human can hear. Well, that is calculated as 1 picowatt per meter square. So this is the sound intensity level. Now let's look at the measurement techniques. There are many ways to measure sound intensity, but today I'm going to discuss the method which is predominantly used in industries, which is nothing but scan and paint. So in order to measure sound intensity, first we need to choose a machine or a noise source. In this case, I'm choosing a pump. And so let me walk you through the instruments required. First, we need a PU probe, which is nothing but a pressure velocity probe. So this probe has two closely spaced microphones right here. So the purpose is first to measure the pressure as is and to measure the pressure gradient between these two microphones. Now pressure gradient, whatever is measured, is actually proportional to pressure particle velocity. So you're going to get the information of particle velocity just by measuring the pressure gradient. And then we need a camera. It need not be a high-speed camera, just a regular camera to capture the object so that we can plot a contour plot in the future. Alright, so I'm going to place it here. And then first you need to cover this machine in grids. So let's cover the machine in grids, and this is how it's going to look like. Now we'll connect the pressure velocity probe to the PC and through a software, and then we'll start the measurement. So during the measurement, the pressure velocity probe is moved along the grid. So it is first moved horizontally, covering the entire regions, and then once it's done moving horizontally, it is moved vertically. So the purpose of moving along this grid is to ensure that you cover every region, and this will be very useful in determining the sound intensity. Now care must be taken you don't shake your hand while moving vertically and horizontally. Alright, once you complete moving horizontally and vertically, you press the stop button and your measurement is complete. Now you press the analysis and the software will do the analysis. The analysis will look something like this. So now this is the contour plot, meaning like you're able to see the machine and you're also able to see the intensity. So red represents maximum intensity, and as the colors get cooler and cooler toward blue, it represents minimum intensity. So now if you study here, this region has the maximum intensity, and these regions don't have they're very, very less intense. So now you can narrow it down. Okay, the source, the source responsible to create noise is right here. Now this is a simple case. It's just a single pump, and you have a simple impeller inside. So obviously this is a region which is expected, the expected source of noise. Now what are the applications of sound intensity? Sound intensity is a powerful tool. It gives insights about the concentration of sound. Now, this information is not provided by sound pressure because sound pressure only gives you the overall level, where sound intensity actually pinpoints as to where the noise is actually coming from. So this is very useful in source ranking, meaning when you have a complex machine. Now in this case, we had a simple machine which was just a pump, and you have less moving parts inside. Now consider a very complex machine with lots of moving parts inside. It becomes actually difficult to identify the source. So sound intensity plays a very important role. You can actually narrow down on the components, like let's say 10 components contributing a lot to the noise, and then you can narrow down to two or three components, and then start working on those components to reduce the noise. So it's a very effective tool. Hey there, let's go through the sound intensity and its types. So the first type is active intensity. Active intensity is that part of intensity that actually contributes to the overall intensity. So it is maximum when the pressure and particle velocity are in phase with respect to each other. So here I have an animation. I'm going to play it for you. So as you can observe how the sound field is expanding, and all the vectors are always outside. Alright, now let's go to the next type, which is the reactive intensity. It's the opposite of active intensity, which is the part of sound field that does not contribute to the net flow of energy. So this occurs when pressure and particle velocity are 90 degrees out of phase, which means the intensity is zero since they both are out of phase. Now let me play this animation. Alright, if you notice here clearly, the arrows are pointing against each other. They're not pointing in the same direction, which means they're canceling out each other. Alright, let's go to the next type, which is positive intensity and negative intensity. The positive intensity is the part of intensity that is moving towards the observer if you're in front of the object, and the negative intensity is the part that is moving away from the observer. Alright, thank you for watching this video. I hope you enjoyed it. Have a great day.